Hello everyone and welcome to our video devoted to migrating legacy databases to CUBA Platform. Sometimes it appears that the underlying stack of technologies used for an application is no longer appropriate for the further software development and support. It may happen for a big variety of reasons. User technology is old and not supported anymore. Legacy application doesn't meet new technical or customer requirements that are hardly implementable using the old stack. Or, finally, you have to support an application developed by a third-party company, but don't have enough experience and confidence in the user technology. Today, we are going to create two applications based on legacy databases. We will use CUBA Studio, a specialized rapid application development tool for CUBA applications. Its built-in migration tool utilizes the well-known reverse engineering approach. During the migration, meta information extracted from the legacy database will be used to complete the following steps automatically. Generate a data model mapped to the legacy database. Update the database to match the CUBA platform requirements. Generate standard CRUD UI. As a result, most routine operations will be handled by CUBA Studio. For the first example, we will migrate world database based on the MySQL world sample. It has a list of cities, countries, and what language they speak. Now we are going to generate CUBA application based on this database. Let's create a new project. Click Create New button on the welcome screen. Set the project name to World. For the remaining fields, leave the default values. Click OK. Now we need to make our application up and running on PostgreSQL. Press Edit on the Project Properties panel. Set database type to PostgreSQL. Make sure the database name is World. Press OK. Now let's move on to model generating from legacy database. Open the Data Model section on the left-hand side navigation panel. Click Generate Model link. CUBA will ask you to update the database in order to create new tables required for the generic platform functionality, such as security management, audit, dynamic attributes, and so on. Confirm the update. Now the Generate Model from Database window appears. Here we will configure the mapping of the database tables and their columns to entities and their fields. Click Show Tables. As a result, the tables existent in the database appear. Click Select All. Press the Next button. At this stage, we can make a fine-grained mapping tune on the level of separate entities and their fields. Select the country language table. Click the Edit Mapping button. The Table Mapping Editor dialog is opened. Here we can change class name, package name, entity name. Another thing we can adjust at this stage is instance name. This is a string representation of an entity that will be displayed in UI, for example in a table cell or a drop-down list. Using these checkboxes, you can add an implementation of some system interfaces. Tick Creatable, Updatable, Soft Delete, and Version checkboxes. Click OK. Select the country table. Click the Edit Mapping button. Tick Creatable, Updatable, Soft Delete, and Version checkboxes. Click OK. Select the city table. Click the Edit Mapping button. Tick Creatable, Updatable, Soft Delete, and Version checkboxes. Click OK. Click the Next button. At this stage, we can automatically generate CRUD screens for the entities to be able to manipulate with data. For each entity, we can choose the type of standard screens: None, Only Browser, Only Editor, both of them, or single screen. If the screens shouldn't be created during the model generation process, they might be created later by Studio means. Uncheck Create Standard Screens. Click Next. When the database is imported, columns for new system attributes should be added to tables. So the corresponding update scripts are generated. Click the Run All Scripts button. Studio warns us that the new model classes and screens will be created in the project and all import scripts will be saved to the corresponding subdirectory and launched. Click OK. Click Close. Our application is done. Let's compile and launch it. Invoke the Run Start Application action from the menu. Studio will deploy a local Tomcat instance in the project subdirectory. Deploy the compiled application there and launch it. Open the application by clicking a link in the bottom part of the Studio. After successful login, let's overview our auto-generated CRUD application. Open Application Cities. Here we can see a list of cities with values from our imported database. We can create new cities and edit existing ones. Open Application Countries. Here we can see list of countries with values from our imported database. Open Application Country Languages. Here we can see list of country languages with values from our imported database. Let's have a short overview of the victim application we are going to migrate. We have picked the official sample project for a fictional vision clinic published on the Microsoft website. The application is based on the Microsoft Light Switch, which was officially abandoned by Microsoft. The sample is a standard free-tier application. It demonstrates the major features of Light Switch: creating data model, screen scaffolding, and calculated attributes in entities. CUBA system tables will be created in the same database as well. As these changes will not affect the tables used by the Light Switch application, the old Light Switch application will retain the ability to run on the same database. Let's have a look at the user interface of the Light Switch application. The application has a classical layout for enterprise software. There is the main menu of the application. Screens are opened as tabs in the same window. So, let's create a new project. Click Create New button on the welcome screen. Set the project name to Vision Clinic. For the remaining fields, leave the default values. Click OK. Now we need to set up the connection to the Vision Clinic database. Press Edit on the Project Properties panel. Set database type to Microsoft SQL Server 2012. Make sure the database name is Vision Clinic. Set password for your SA account. Click Test Connection. If you get the connection successful message, click OK to save the changes. Now let's move on to model generating. Open the Data Model section. Click the Generate Model link. Click the Setting button on the top panel to configure the global mapping options. In our example, both frameworks track who and when created or updated records in the database. So, map the predefined CUBA fields to the corresponding system columns in the existing database, which exist in most tables. Row version is another system column used by Light Switch for optimistic locking. Unfortunately, it cannot be mapped to the version column used by the platform for the same purpose, because the types of those fields do not match. We could add another field to support optimistic locking for the CUBA application, but as we have decided to avoid changing the structure of the existing tables, we will globally exclude this column from mapping. Click the plus button to add a new exclude mapping. Enter name row version and click OK to save the settings. Click Show Tables. Click Select All. Press the Next button. By convention, all entities in CUBA should be named in singular form, mainly because Studio auto-generates default strings used in the user interface, for example in menu items and screen names. So we will modify entities to be called in the singular form. Select the Appointments table. Click the Edit Mapping button. Edit the class name Appointment. Edit the name Vision Clinic Appointment. Click OK. Let's do the same mappings for the rest entities named in plural: Invoice Details, Invoices, and Patients. Select the Invoice Details table. Click the Edit Mapping button. Edit the class name Invoice Detail. Click OK. Select the Invoices table. Click the Edit Mapping button. Edit the class name Invoice. Click OK. Select the Patients table. Click the Edit Mapping button. Edit the class name Patient. Click OK. Select the product table. Click Edit Mapping. Select the product name field in the instance name column combo box. Click OK. Click the Next button. For invoice and product, select None for standard screens as we will tune these entities a bit. For invoice detail and product rebate, we need only editor, as they will be used within invoices and products respectively. For appointments, select single screen. Click Next. No update scripts have been generated for the existing tables, just as planned. Click Save to proceed. Click OK. Click Close. Now we need to configure our entities to match the light switch application. Select the invoice entity. Click Edit. Invoices have one-to-many relation to invoice details, so let's add this relation. Click the New button under the Attributes table. Set name, Details, Attribute type, Composition. Type, Invoice detail. Mapped by field is filled automatically as invoice detail has link to the invoice entity. Click Add. Now pay attention that invoice status attribute has integer type. Let's have a look on how this attribute is represented in the light switch application. We can see that this attribute is represented as an enumeration. So let's create the invoice status enumeration. Click OK to save the entity. Click New Enumeration. Set class name Invoice status. Click Add. Set name Active. Set ID 0. Click Add. Set name Paid. Set ID 1. Click Add. Set name Overdue. Set ID 2. Click OK. Now let's change type of invoice status from integer to invoice status. Select the invoice entity. Click Edit. Select invoice status attribute. Change attribute type to enum. Set type invoice status. Click OK to save the entity. Now let's configure the appointment entity. Select the appointment entity. Click Edit. Pay attention that appointment type attribute has integer type. In the light switch application, this attribute represented as an enumeration. So let's create the appointment type enumeration. Click OK to save the entity. Click New Enumeration. Set class name Appointment type. Click Add. Set name Annual. Set ID 0. Click Add. Set name Follow-up. Set ID 1. Click Add. Set name Emergency. Set ID 2. Click OK. Now let's change type of appointment type attribute from integer to appointment type. Select the appointment entity. Click Edit. Select appointment type attribute. Change attribute type to enum. Set type appointment type. Click OK to save the entity. Now let's configure the product entity. Select the product entity. Click Edit. Products have one-to-many relation to product rebates, so let's add this relation. Click the New button under the Attributes table. Set name Rebates. Attribute type Composition. Type Product rebate. Mapped by field is filled automatically as product rebate has link to the product entity. Click Add. Click OK to save the entity. Let's have a look at light switch application one more time. For products, I see current price attribute. For invoices, tax, subtotal, total attributes, but I don't see such attributes in the data model. This is because these attributes are calculated. Now we are going to add these attributes to our application. Select the invoice detail entity. Click the IDE button. The studio will generate project files and open the project in the IDE. Here we can see the source code of the invoice detail entity. Let's add method for calculating subtotal value. Our method is annotated with meta property annotation. This annotation indicates that metadata should include the annotated attribute. This annotation can be set for a field or for a getter method if there is no corresponding field. Meta property is mainly used for defining non-persistent attributes of the entities. Open the source code of the invoice entity. Let's add methods for calculating tax, subtotal, and total values. Open the source code of the product entity. Let's add method for calculating current price value. Now we need to add the localization keys for our meta properties. Open the message properties file inside entity package and add the following localization keys. Now we are ready to create standard screens for invoice and product entities. Select the invoice entity. Click New Generic UI Screen. Select Entity Browser Editor. Invoices have relation to the invoice detail and patient entities, so our data source should load these fields along with the simple fields of the invoice entity. For that purpose, CUBA uses views, an XML description of what entity attributes should be loaded from the database. Click the plus button to create a new view. Specify the name Invoice Browse. Select Invoice Patient attribute and specify the minimal system view for it. Select Details attribute and specify the local system view for it. Select Product ID attribute and specify the local system view for it. Select Subtotal attribute. Also, select Subtotal, Tax and Total attributes. Click OK to save the view. Specify the same view for the Edit View field. Click Create. Click Close. Select the product entity. Click New Generic UI Screen. Select Entity Browser Editor. Specify the minimal view for Browse View field. Similarly to what we did for the invoice entity, click the plus button to create an extended edit view for the product entity. Rename the view to Product Edit. Select Rebates attribute and specify the local system view for it. Select Current Price attribute. Click OK to save the view. Click Create. Click Close. Let's compile and launch our application to see what we have for now. Invoke the Run Start Application action from the menu. Open the application by clicking a link in the bottom part of the studio. Open Application Appointments. Here we see the master details screen with appointments. Appointment type is represented with enumeration. Open Application Patients. Here we see the list of patients. Open Application Invoices. Here we see the master details screen with invoices. Invoice status is represented with enumeration. The detail part of the screen is represented with two tabs. The first tab is for main information. The second tab is a list of related entities. Open Application Products. Here we see the master details screen with products. The detail part of the screen is represented with two tabs. The first tab is for main information. The second tab is a list of related entities. The product screen is missing the similar products table and the product image. With CUBA Platform and Studio, we can easily polish it up to look similarly to the original screen from the light switch application. Go to the Studio, open the generic UI section, select Product Browse and click Edit. Add a new group box to the main tab. Set ID Related Products box. Set Caption Related Products. Select the main tab. Set Related Products box for the Expand field. Add a new table to the Related Products box. Set ID Related Products table. Set height 100%. Set width 100%. Go to the Data Sources tab. Click the New button. Set type Collection Data Source. Class name Product. ID Related Products DS. View Product Edit and change query. Select a newly created data source for the Related Products table. Now we need to add the components for displaying product image. Select Field Group. Open Context menu. Invoke wrap into HBox. Select Horizontal box. Set spacing True. Add a new embedded component to the horizontal box. Set ID Product Image. Align Middle Center. Height 250 pixels. Add a new File Upload field component to the horizontal box. Set ID Image Upload. Align Middle Center. Accept JPEG and PNG files. File size limit. Show Clear button True. Select Embedded and File Upload field components. Invoke wrap into VBox. Select Vertical box. Set spacing True. Click OK to save the screen. Now we need to add logic to convert byte array to image and vice versa. Click the IDE button. Go to the IDE, open the screen controller, add the following methods. Now we need to add invocation of these methods and some logic for handling image upload. We need to add generator for product image column in the related products table. Go to the screen descriptor. Add generated product image cell attribute to the product image column. Additionally, add max text length 30 to the description column. Now let's reopen the product screen and see our changes. The main goal of our video is reached. We created two applications based on legacy databases. For that purpose, we used CUBA Studio and its built-in migration tool. As a result, we generated a data model mapped to the legacy database, updated the database to match the CUBA Platform requirements, generated standard CRUD UI, and added a business logic to match the original application. Thanks for watching.